biochemistry, bioscience, biotechnology from various universities across the country. It is a great pleasure and honor for me to speak something related to the mulberry improvement and its future perspective and insight. My specialization is silkworm physiology and biochemistry, biotechnology, and molecular biology, which I was taught for the more than 24 years of my total put-on service in the University of Mysore in the campus. And today, the topic which I have chosen for the benefit of the participants from the life science refresher course, the mulberry improvement and its future perspective and insight. Is it audible, sir, for all the participants?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, madam.
Yes,
Thank
sir.
you. Okay.
Yes, sir.
Firstly, I would like to give a general an introduction of this Morus alba. Morus alba is commonly called as mulberry. It is a fast growing deciduous green, grow in different forms all over the country, especially in South India, Andhra Pradesh, Tamil Nadu, Karnataka. This mulberry is grown as a perennial crop for the robust growth and nutritious food material for the growth and development of mulberry silkworm in terms of production of the cocoon. Cocoon that are used for the raw silk production. Again, in turns, it has been utilized for the fabrication in the form of saris, silk saris, and there are different types of silk saris, a Mysore silk, Pochampalli silk, etc. This mulberry has a different types of cultivation: Morus alba, Morus lavigata, Morus serrata. These are the different genotypes which have been used for the cultivation in the South India. Morus alba is a low bush form. It has been cultivated in a short form and limited growth in order to increase the girth of the plant. And Morus alba is a medium bush form. It is elevated its height compared to the Morus alba. And the Morus lavigata as a high bush form. Again, it is comparatively better in terms of height and the productivity of the mulberry leaf. And it is also established in the form of Morus lavigata in the form of a tree, and Morus serrata as also in the form of a tree. These are all the 5 different photographs which I wanted to exhibit before you that has been cultivated since long time, more than 3,400 BC, a very traditional in the form of a tree. And slowly it has been domesticated and cultivated and utilized for the as a food material, a sole source of the mulberry silkworm. And this propagation has been adapted or cultivated in terms of seeds, seedlings, stem cuttings, saplings, and grafting. Normally, the mulberry is highly heterozygous, a perennial crop. It is domesticated, cultivated in the field, either in the temperate region or in the tropical region. And therefore, it has been increased the girth and the width of the plant and also the productivity parameters in terms of propagation through the seedlings or saplings. And seeds are also used but it is very, very tough job, difficult when we raise the propagation through seeds. And stem cuttings is the another form of propagation adopted especially in the subtropical continent as a perennial crop in order to increase the heterozygosity and also the sprouting capacity of the plant. And the grafting is also practiced to make the union of the scion and the stem in order to make the heterozygosity mixed with the scion and the stalk. To improve the varietal expression, capacity of manifestation of economic parameter, productive parameter, and such propagation is possible only through grafting. The seeds is the least expensive, most rapid mode of propagation. Seeds are not practiced for the propagation. It is very, very inconvenient to the investigation of the embryogenesis, expression of root, expression of leaf, expression of the fruit. Therefore, the best method of propagation is possible only by the saplings. The lack of inbred lines and heterozygosity of the parents hampers the propagation through seeds. And stem cutting retains the desirable characteristics of the parental material without any changes. Since it is economically important, a beneficial crop, it has to be practiced only for the expression of the desirable characteristics of the plant and economic values of the plant in different continents, different climatic zones, different peninsular component. The success of rooting from stem cuttings depends on the genotype selection, environmental factors associated, and physiological state of the cutting for the propagation. Any cultivation of a crop, agricultural crop, horticultural crop, and the mulberry crop, ornamental crop, etc., are going to be expressed. Their capacity of the expression depends on the genotype, environmental factors associated, and the physiological state of the cutting which has been used for the propagation. And there are some species and varieties which we observe all over the country. There are about 68 different species under the genus Morus. The majority of them occurs in Asian continent. Especially in China, there are of 24 species, and Japan 19 species. Continental America is also rich in its Morus species, and genus is poorly represented in Africa, Europe, and Middle East, and it is not present in Australia. The reason is that because of the temperate region, the cold situation, torpor for the sprouting of the mulberry at the early stage of development, and these countries are not the congenial environmental conditions are not facilitated for the growth and development of the mulberry. In India, there are many species of Morus, of which Morus alba, Morus indica, Morus serrata, Morus lavigata grown wild in Himalayas. There are several varieties have been introduced belongs to the Morus multicalis, Morus nigra, Morus sinensis, Morus philippines. Most of the Indian varieties of mulberry belongs to Morus indica. If you look at the cytological set of the chromosomes, ploidy behavior, which are different among the different species of the mulberry. The ploidy and the chromosome numbers and also species which varies in a very diversified manner. Haploid number of 14 chromosomes in Morus notabilis, diploid chromosome, that is 28 in Morus alba, Morus indica, Morus latifolia, Morus multicalis, Morus australis. And triploid number 32 in Morus bombycis, tetraploid, that is 56 chromosomes in Morus lavigata, Morus cathiana, Morus bonensis. Hexaploid, the n number becomes 6 times and the chromosomal numbers are 84 in Morus serrata, Morus telifolia. Octoploid, that is 112 chromosome numbers in Morus cathiana, and decasoploid, there are about 308 chromosomes. The maximum chromosomes have been observed in the mulberry varieties Morus nigra. That is 22N number. The chromosomes are very, very minute, small, and very, very difficult to identify under normal microscope. The cytological investigation shows that the diversified behavior of the chromosome, heterozygosity, because of the variations in the number of chromosomes, the presence of the genes in each chromosomes are also attributed in terms of expression of various physiological, morphological, anatomical characters of the plant in order to express the quality and the quantitative parameters of the mulberry Morus variety. And there are some significance attributed in terms of the leaf, in terms of fruit, in terms of root and bark, wood and seed. This leaf mainly which is used as a food sole source for the silkworm domestication and also animal feeding. Leaf is highly rich with protein, minerals, high moisture content, and macro and micronutrients, which are the essential commodities required for the growth, development, and the metamorphosis of the Silkworm bombyx mori. And fruits are rich with sugar, carbohydrate, alkaloids, vitamins, fat, minerals, amino acids, carotenoids, flavonoids, and antioxidants. And similarly, the root and bark, which are purgative, anthelmic, astringent properties, also rich source of the phenolic compounds such as macrolin, rutin, isoquercetin, resveratrol, and morin, which are having a significance in terms of the astringent properties, anthelmic properties, purgative properties attributed especially in the root and the bark. And the wood is comparable with the teak as regards to the shock resistant ability, eye strength, hardiness, sport articles, and ternary items which have been used from the traditional and ancient varieties of mulberry, especially from the wood region. And the mulberry seeds contain about 25 to 30% of oil, which are useful for cooking. And we need to have a lot of research work. It has to be emphasized, especially for the seeds and how this oil can be used for the cooking purposes. And mainly, it has been extracted, isolated, purified, then it has been recommended. Mulberry has a multi-purpose plant. One mulberry tree is able to absorb 4,162 kg of carbon dioxide and releases 3,064 kg of oxygen in every year as per the GOES has conducted an experiment in the year 2017. The another one is the Spurti, the mulberry leaf health drink, which is also very, very important, and it has an antioxidant properties in the form of it. And it has environmental safety measures, promotion of human health, animal husbandry, economic empowerment or women empowerment, and wide distribution and flexibility in cultivation, nanoparticle synthesis, biofuel production, medicinal plants, industrial applications are the main, multi-purpose obtained from the mulberry. As per the study carried out by Rohela in the year 2020. It has a significance contribution for the human health and also environmental safety measures, industrial point of view, they are contributed from the mulberry. If you look at the history of the sericulture in India, it has a full 4 varieties of silk obtained. One is mulberry silk, Eri silk, Tassar silk, Muga silk. The mulberry silk, Bombex mori. Eri silk, Felisomia resini. Tassar, Antheria mylitta, and the another one is the Muga silk. The foreign exchange about 1,773 crores per annum recorded in the year 2022 to 2023 in Central Silk Board and practice more than 55,300 villages all over India. Employment opportunities increase up to 92.03 lakhs people in the year 2022 to 23 as per the record from the Central Silk Board, Ministry of Textile. And the raw silk production over 33,845 metric ton in the year 2023 and 2024 very recently. And sericulture, in which the production of the raw silk occupies a second place, and it is the second largest producer, and 40% of the world production only from the India. And the China is also a major country, contribute 54.8% only from the China as per the International Sericulture Commission sources. The raw silk production in India in the year 2022 to 23, mulberry plantation were 2,53,182 acres, and bivoltine raw silk production about 8,900 metric ton, and crossbreeds 18,750 metric ton, and total of 27,654 metric tons of raw silk production as per the data in the year 2022 to 23. One disease-free layings contain about 450 to 500 eggs. It needs 12 to 15 kgs of mulberry leaves for the domestication of the silkworm. 1 kg of cocoon needs 18 to 20 kgs of mulberry leaves. On an average, for 100 DFLs, about 60 to 70 kgs of cocoons approximately obtained from the 100 DFLs, disease-free layings of crossbreeds or bivoltine hybrids. Even the average become 70 to 80 if you choose a double hybrid or foundation cross, namely FC1 into FC2, which are most commonly recommended or used in the present scenario for the increase the synthesis or the production of the raw silk in the recent years. Mulberry cultivation in India, though mulberry cultivation is practiced in various climatic zones, the major area in tropical zone covering Karnataka, Andhra Pradesh, Telangana, Tamil Nadu, and Maharashtra states, which account for about 90% of the total area under mulberry cultivation, including irrigated and rain-fed conditions. In the subtropical continent and temperate zone, the West Bengal, Himachal Pradesh, Jammu and Kashmir and northeastern states have major areas under mulberry cultivation. Contributes a lot for the production of the increase of raw silk production and also area for the domestication of the cultivation of the mulberry in India. We have mulberry germplasm at CSB, CSGRC Vasur, Central Silk Board, Central Sericulture Germplasm Resource Center at Vasur, in which about 1,006 indigenous and 285 exotic exceptions of mulberry are maintained in the mulberry germplasm. This is one of the biggest institute located in Tamil Nadu in South India, has a large number of genotypes, exotic varieties, indigenous varieties evolved by various scientists who are all working hard to increase the yield parameter, increase the resistant capacity, to increase the pesticidal resistance, increase the insect pest resistance at the field level. Such varieties, I want to list few, and Morus indica, Morus alba, Morus lavigata, Morus serrata, Morus rubra, Morus cathiana, Morus nigra, Australis, Morus bombycis, Morus sinensis, Morus multicalis, Morus rotundaloba, and Morus tilifolia. And these are all the varieties collected from different countries, almost 30 countries, from countries of the 30 countries, it has been collected and preserved, and accession are maintained in the mulberry germplasm at CSGRC Vasur. And these are all the varieties which are identified: local varieties, Kanwa 2 variety, S36 variety, Victoria 1 variety, and G4 variety. In the year 1949, in the traditional India, after the independence, about 18 metric tons per year per hectare was the yield. Very traditional and low yielding variety. And over a period of a time, in the year 1975, the another variety called K2, Kanwa 2, the increase in the yield of 30 metric tons per hectare per year. Over a period of another 10 years, in the year 1986, S36 varieties was evolved and increases the quality and the quantity parameters from 30 metric tons to 40 to 45 metric tons per year per hectare, only contributed from S36. In 1997, the V1 variety is called as Victoria 1, the 55 to 60 metric ton per hectare per year contributed from V1. And very recently, in the last 10 years, 60 to 65, even 70 metric tons of the yield contributed from G4 genotype 4 per hectare per year contributed from G4. Over a period of the 70 years, the quantum and the quality and nutritive value of the mulberry varieties were evolved, a drastic changes in terms of productivity, in terms of the quality and the quantity of the mulberry variety. The subtropical and the temperate regions, some of the varieties which are suitable for subtropical continent, and some of the varieties which are suitable for a temperate climatic zone, where the farmers, scientists were all working for the cultivation at the field level and domestication of the silkworm in the rearing house. There are some factors mainly responsible for the productivity quality and the quantitative parameters manifested at field level, and such factors mainly the irrigation and input. A sufficient amount of irrigation and sufficient amount of inputs are the main sources collectively responsible for the improvement of the mulberry variety. So that the harvesting of the mulberry varieties leaves for the domestication of the silkworm, you could able to get a good quality cocoons and good quality raw silk, which fetches high cost. And secondly, the abiotic factors, soil moisture stress, soil alkalinity, salinity, and acidity. Soil moisture stress is the one which is mainly causes at the root level. Soil and alkalinity is another factor which is also equally responsible for the growth and development of the root. Acidity and salinity is also another abiotic factor, collectively helps for the influence of these abiotic factors in order to express the high yielding, good quality and nutritive leaves from the mulberry. And biotic factors, root diseases, root knot disease, root rot disease, and some of the major pests like mealybugs, thrips, leaf roller, Bihari caterpillar. And these are also helps for the causing the diseases, expression of symptoms, and reducing the quality and the quantity of the mulberry leaves. So these factors are affecting the mulberry crop yield. In the year 2023, anticipated in future, the area of cultivation of the mulberry plantation in the year 2016 to 2017, year-wise, the increased projected mulberry cultivation or area is slowly increases. In the year 2029 to 30, probably 3 lakhs per acre is the vision anticipated by researcher to see that the productivity, see that the increase in quality, increase in the quantum of production of cocoon. At the same time, the raw silk production is anticipated. So it was 2.27 in 2016, and gradually there is a trend in the area of increase of the mulberry cultivation or the area of mulberry cultivation anticipated by 2030. And what are the factors we could able to concentrate as a researcher or a stakeholder or a farmer or a teacher or a scientist? What could be the sources which you need to consider for the betterment of the expression of mulberry, either through a breeding, either through inbreeding, outbreeding, conventional breeding, mutational breeding? What are the factors which are associated in order to influence the expression of the quality and quantitative parameters? In the early stage, the selection is the one among the cultivars, among the genotypes for a wide adaptability and the yield. Mysore local in South India and Bombay in West Bengal are the two varieties which was traditionally recognized for the adaptability and high yield. And Mandalaya from Myanmar, that is S1 and Gosarami in Kashmir. So these are all the traditional early genotypes recognized for the investigation and slowly adapted, subjected for the observation, investigation, and the recording of the data in terms of the yield, in terms of adaptability, in terms of the production of the mulberry yield. The systematic breeding is very, very important prior steps associated to intricate the behavior study and the observations. It is an open pollinated hybrid selection. As I said in the beginning, Kanwa 2, K2, and RFS 135, RFS 175, S13, S34, AR11, S799, S1635 are the open pollinated hybrid selection. We have to allow them for a open pollination and categorically, systematically, we have to analyze the behavior of the mulberry variety and their expression of the characteristics. Controlled pollinated hybrids, V1, G4, G2, RC1, etc. And polyploidy breeding is very recently, many scientists, researchers adopted for the improvement of the mulberry variety. AR12, TR10 are the varieties which have been developed by polyploidy breeding. The another one, the mutation breeding, S36 is developed, and advanced generation breeding, that AGB8, another variety which are developed. This is the evolutionary trend for the development of improvement of the mulberry varieties which are suitable for different climatic conditions, either of temperate or the subtropical continent, attributed their expression in connection with the influence of abiotic, biotic factors in the particular climatic condition. The objectives of the breeding mainly concentrated by the researchers to improve the yield and quality of the mulberry variety. And secondly, the tolerance to biotic and abiotic stress. And varieties for suboptimal conditions. When they look for the objectives, what are the problems and how to overcome some problems and what are the advantages from these objectives for the benefit of farmers, scientists, researcher, that has to be addressed over here. Long generation time. The breeding in an open field in an environmental condition attributed a long generation time. Very length, high duration of the experimentation is more. And advantage is easy to fix the heterosis or the hybrid expression, since it is a highly heterozygous variety attributed in the mulberry genotypes. And second problems is poor relationship between juvenile characters and adult stage. The juvenile characters are slowly disintegrated when there is a maturity of the plant, and such characters are going to become dominant and juvenile characters are diminished. And what are the advantages from the second point? The large variability required for success of conventional breeding. When the plant is highly heterozygous, there is a possibility of the expression of the various variable characters. mutational characters, instantaneous expression characters, spontaneous mutation, chemical mutation, etc., which are going to be accomplished for the large variations and success of conventional breeding. And non-availability of pure lines. The pure lines are very, very difficult in the mulberry breeding program, since it is highly perennious, heterozygous variety and has a capacity of high adaptability or the plasticity. Any plant has heterozygosity, range is extremely high, which has a wide range of adaptability, wide range of plasticity that has been observed, and mulberry is the one of the a good example for high plasticity. Since it is a highly heterozygous and perennial crop. What are the methods or strategies for the improvement of the mulberry? First one is the collection, characterization, evaluation, conservation, and utilization of germplasm. So collection from different agroclimatic zones, different temperate zones, different subtropical continent regions, and such collected genotypes are to be subjected in a particular area, protected area, safe area for the improvement of the particular mulberry genotype. And second one is characterization. When you brought something from outside, you must protect them in a conserved way or a protective area to characterize and understanding the behavior, salient features, morphological features, physiological feature, anatomical feature, and etc. And over a period of a time, once it has been characterized in a particular environment, and over a period of 3 years, we have to assess them. Evaluation. There are some 20 to 30 parameters are need to be assessed, are evaluated, addressed, and documented for the further utilization, further conservation, further breeding program. The conservation is an important task or the important step. We have to conserve all the genotypes collected, characterized, evaluated in a environmental safety point of view. And such conserved material, biomaterial, genotypes are subjected for utilization in terms of improvement, in terms of hybridization, in terms of bagging, in terms of the increase the robust growth, disease resistance purpose, insect pest resistance purpose, and also the quality and the quantity of the mulberry genotypes. When we subject it for hybridization, we have to screen them meticulously. We have to assess them seriously for the selection of the hybrids. If you want to select certain hybrids, you must know the advantages and disadvantages of the varieties which you collected from different sources all over the countries. And the suitable variety we have to isolate. And isolated variety has to be recommended based on the performance of the plant, based on the efficiency, potentiality of the mulberry genotypes obtained in a particular protected environment. Before releasing to the farmers, we must assess them and document it and patent it. Then it is possible to release to the farmers. And trial and error is one of the important tasks that we have to be carefully considered and assess the attributes of each mulberry genotypes. Probably helps for the betterment, suitability for the farmers. Induction of mutation and utilization. The another strategy or the method is induction of mutation. Mutation, as you know, all of you, as a biologist, a teachers, a change in the gene, a alteration at a molecular level, DNA level, could also express in terms of phenotypic character. A small changes by induction of a mutation, it is called frame shift mutation, point mutation, chemical mutagenesis or used, radiation mutagenesis, and spontaneous mutagenesis, etc., are used for the ethyl methyl sulfonates are the two chemical mutagens are used for the induction of polyploidy, mutational changes, variation in the chromosomes, alterations in the gene, and allowed for the expression of a genotypic expression in terms of phenotypic character and assess the expression of such gene, and if it is harmful, and that we have to be carefully, meticulously assessed and again subjected for the causes. And if there are beneficial mutations, and such mutations are used for the benefit of improvement of the economic characters, productive characters, and such genotypes are utilized for the purpose of the research further and farmers' recommendation. And polyploidy breeding, as I mentioned in the previous slide, the polyploidy increase in the number of chromosomes, N, 2N, 3N, 4N, and it is going to be the addition of number of chromosomes. The ploidy behavior is also helps for the accomplishment of large number of the phenotypic character since the chromosomes are increased. Since the number of chromosomes are more, the number of genes are also parallelly increases, and the expression of control of a gene characters also attributed in terms of the phenotypic expression. Therefore, it is become highly heterozygous. Heterozygosity is nothing but a large characters documented in the genes. And the triplets are the better sources, useful sources, rather than diploid and tetraploid. When increase the number of ploidy, probably there is a deterioration of the expression of character, malfunctioning, malformation, anomalies, disintegration of characters, etc. are going to be observed. The triplets are the most suitable, evolved, high-yielding, and such varieties of mulberries are most preferable and recommended to the farmers to increase the yield parameter and the productive parameters. And the fifth strategy for the improvement of the crop, biotechnological approach, genetic engineering. This is the one we have a more of knowledge, more of skill, meticulous utilization of our mind and soul when we look for biotechnological approach for the improvement of mulberry crop. Even the genetic engineering requires a lot of knowledge, idea, and a meticulous, thorough observation before assessing the variety, which whether it is fit for the farmers, suitable for the farmers. the biotechnological approach. The insertion of a gene, a desirable gene on our own interest, probably has to be introduced for the particular character, and that is going to be multiplied through a vector system introduced to the host plant, and that helps to see that there is a novel character. Phenotypically and internally, a novel protein, genetically engineered novel protein, expressed, and it has a lot of scope, lot of inheritance and transmission of a character from one generation to the another generation, that has to be observed, that has to be recorded, that has to be documented. And the gene to gene interaction, protein to protein interaction, environmental interaction, and expression of the various characters phenotypically are going to be collectively contributed for the development of a new variety, and that has been to be very, very useful for the present scenario. How to develop a mulberry variety? Or evolution of mulberry variety. As I mentioned in the beginning, highly heterozygosity, germplasm evaluation and selection of the parents are very, very important, which plays a dynamic role for the expression of a future progeny lines or a new lines, which are possible only by hybridization and rising of a new progeny. Germplasm screening, we have to fix the character, which character we are going to be addressed, understanding, realizing the performance of the gene in a particular genotype. Then we can fix the character which is going to be expressed out of particular gene which we are looking for. You fix a character, say for example, chlorophyll content. Say for example, for the expression of a drug in a particular which is resistant to the pest. Secondary metabolites, hormonal regulations, disease resistance, pesticidal resistance, etc., etc. When we fix a particular character of our interest of a gene, we could see that we could isolate a desirable progeny and evaluation under PRT, primary retrieval trials, a primary yield evaluation. So when we look for a particular primary, a trial, that helps for the evaluation. So you show that there is an improvement in a particular variety that has been going to be utilized for the further improvement, and slowly we could improve such varieties, and final yield we can anticipate. Altogether, to develop a variety, 6 to 7 years. Earlier it was 4 years, until the registration of the variety, patenting of the variety, development of the variety for the farmer's use, altogether 4 to 5 years of duration, or meticulous observation, investigation for the recommendation of a particular variety, especially in the highly heterozygous varieties. And mulberry is the one which is a most suitable example for heterozygosity, ploidy investigation, etc. And mutation breeding in mulberry, S13, S34, S36 with enhanced drought tolerance from seeds of Berhampur local in West Bengal, 0.1% and 0.3% ethyl methyl sulfonate is effective in inducing a mutation. Mutation is a change in the gene, though the gene is very, very minute. a small microscopic and introduce such changes at the gene level, and EMS is recommended at a very a low level of concentration of 0.1 and 0.3%. And some somoclonal variants, SV1 developed from S1 showed increased branching, tolerance to drought, higher leaf field. Another somoclonal variants from S14 showed a beneficial traits like shorter internodal distance, thicker leaves, higher chlorophyll content, higher moisture content, and better moisture retention capacity. So somoclonal variants are accomplished with large number of beneficial character in a mutational breeding, especially in mulberry. And polyploidy breeding, where the triplets have several qualities such as fast growth, higher rooting, better nutrition, stress resistance, etc. Tetraplets have a slow growth, rough leaf, poor palatability due to bigger cytolith, leaf wear, and thick whitting. That is the difference between triploids and tetraploids. And a number of natural tetraploids are available in the field, especially in CSGRC, Osuru, that is Tamil Nadu, and Central Sericulture Research Training Institute at Berhampur in West Bengal. And in Mysore, we have a Central Sericulture Research Training Institute where the many scientists were all working on the polyploidy breeding, and they are contributing a lot for the improvement of the mulberry varieties. Colchicloids are developed from good diploid through colchicine treatment. All of you are aware of it. The colchicine is a mutagenic agent that is used over here for the treatment of colchicine to the mulberry variety, mulberry genotypes. We could able to develop another new variety, and where the polyploidy has been established. And that is going to help for the boosting the economic parameters, qualitative parameters, quantitative parameter in the economic point of view. And CSRNT Berhampur, there are about 32 tetraploids are induced, and several tetraploids are developed. Out of them is S1635, triploid 10, triploid 23 were authorized for the cultivation at farmers level. This is the one we need a high intention and orientation to the farmers level, and farmers are much more benefited by these tetraploids. And Mysore CSRNT has developed a number of tetraploids from high yielding varieties and are used in the breeding program accomplished. Year 2, a new variety has been developed for alkalinity soils, and that is also another contribution made for the salty, salinity soil. These are all the varieties which are developed by Mysore CSRNTI: irrigated condition, rain-fed condition, resource constrained condition, alkaline soil, intercrop with coconut plantation, exclusive chalky garden. And these are all the inputs, NPK in the ratio of 350, 140, 100 kg per hectare per year, FYM 25 metric ton per year per hectare, and varieties which are recommended for irrigated: S36, Victoria 1, and G4 variety, and the potentiality of the yield from the irrigated condition of S36 and B1 and G4 variety are 65 metric tons per hectare per year. Whereas under rain-fed condition, assume that it is of lower yield, even though input is also lower, and the variety which are recommended is the S13, S34, MSG2. And the potentiality of the yield contributed is very much limited, 13 to 16 metric ton per year. Resource constrained conditions, RC1, RC2 varieties are used. It is about 23 to 25 metric tons per year per hectare. NPK is 150 is to 60 is to 60 recommended in terms of kgs, and FYM about 10 metric ton per year per hectare. And alkaline soil about 300, 120 and 120 kgs per hectare per year. And AR2, AR12 variety is most preferably used for alkaline soil, and the yield potential is 24 metric tons per hectare per year. And intercropping is also possible with mulberry and coconut plantation, coconut plantation. That variety is called Sahana. Sahana is the most convenient variety practiced for intercropping, coconut plantation at the recommendation of inputs about 300 is to 120 and 120 kgs per hectare per year, and farmyard manure of 20 metric tons per hectare per year. And yield potentiality is about 30 metric tons. And there is a variety called G2, very recently developed from CSR&T Mysore. And G2 variety is genotype 2, and it is exclusively recommended for the chalky garden, for the leaf harvested or used for the first and the second instar silkworm, and NPK is recommended about 240 kgs per hectare per year. And farmyard manure about 60 is to 140 is to 140 metric ton per hectare per year, and yield contributed about 35 metric tons per year per hectare. And these are all the varieties contributed or developed by CSR&T Mysore for the farmers' benefit, research benefit, and the interaction with the scientists from different countries and within India. There are some characteristics of the mulberry genotypes assessed. As I mentioned, Mysore local, it is a very traditional ancient variety. Thin lobed leaves, low moisture content, retention capacity, and high rooting ability of 90%. Leaf yield about 4 to 5 metric ton per hectare per year under rain-fed condition. This is suitable for rain-fed, not for the irrigated condition. 18 to 20 metric tons per hectare per year under irrigated condition, possibly obtained. And another one is Kanva 2, selection from natural population. It is a green, entire, medium-sized leaves, high rooting ability, leaf moisture content, protein content 20%, 21%, leaf yield is 8 to 12 metric tons per year per hectare. Under irrigated condition, about 30 to 35 metric tons per hectare per year under irrigated condition. Dear parents, are you feeling boring?
No, sir. No, sir. No, sir.
Is it okay for you all?
Yes, sir.
Yes, sir.
I want to know your
Good
attention
explanation.
that I am going to share to you all whatever the things which I know, I am familiarly working on it. And you are all the participants from different colleges, scientists, etc., etc. And your area interest might not be, I am fully not understood. But I want to convince you all that you feel happy, you feel comfortable. Is okay?
Sir,
Yes,
it's
sir.
good-
Yes, definitely.
It's good to learn something new which we don't know.
Yeah, yes. You are all from botany zoology background?
Yes, sir.
Sir.
Good, good.
So we are from microbiology also.
Yeah, that's good.
Yeah.
Then S36, it is recommended in the year 1984, selected from Barampur by EMS, chemical mutagen, ethyl methyl sulfonate. It is a mutagenic agent which are used for the developing a variety S36 from Barampur, that is in West Bengal. A central sericultural research training institute in Barampur at West Bengal. And it has a thick pale green leaves with highly cordate leaf base and about 48% of rooting ability. This is very, very important for the plant, rooting ability. moisture content of 80%, moisture retention capacity of 82%, and leaf yield is enhancing from 38 to 42 metric ton per year per hectare, and 28 metric tons per hectare per year chalky leaves under 8 crop schedules. So this is the variety for irrigated condition. And now V1 variety, V for Victory. Percentage of S36, sorry, parentage of S30 crossed with C776. It has a large, thick, dark green, ovate leaves, high rooting ability, moisture content, moisture retention capacity of 80%, leaf yield comparatively with other S36, Kajali, Mysore local, it is about 60 metric tons per hectare per year. And protein content is also high, about 27%, carbohydrate is of 28%, chlorophyll is about 0.37%, and leaf cocoon ratio is 18:1. And harvesting index that is calculated based on the available area and number of plants. So that is 0.59 in V1 variety. And this is very recent, G4, in the year 2010, this variety is developed. This parentage is of Morus multicalis and S13. This is called G4, genotype 4. It has a thick, entire, glossy, dark green leaves with a waxy lamina, highly nutritious variety, and moisture content is of 75%, and moisture retention capacity of 78%, high rooting ability is more than 90%, leaf yield about 65 metric ton per hectare per year, and protein 26, carbohydrate 25, chlorophyll 0.27%, and leaf is to cocoon ratio is 19:1, and harvesting index is of 0.61 in terms of the percentage observed in genotype 4. And genotype 2, another variety, it is also almost similar except the rooting ability. It is of 94%, and the parents are Morus multicalis and S34, and it has a quick sprouting capacity, and it is most suitable for chalky worms, first and the second instar silkworm, especially for crossbreeds, foundation crops, double hybrids. This high rooting ability of the genotype 4 is recommended, and it improves the molting of 97%. This is the one a special character observed, improved molting. The molting percentage in silkworm is about 97%, and high larval weight after first molt. And we could compare with other breeds like crossbreeds, double hybrids, foundation cross, multivoltines, bivoltines, pure lines, trimoltar, tetramoltars, and pentamoltars. And protein is of 27%, carbohydrates of 25%, chlorophyll is 0.36%, and harvest index is 0.55. This is genotype 2, also developed from the CSRT, Mysore. The S13 that is developed in the year 1990, and the selection from K2OPH parentage, it has erected branches and moisture content of 78%, protein content of 23%, carbohydrate content of 27%, fast generation after stress elevation. This is most suitable for stress situation, that is S13. Rooting ability is of more than 80%. The leaf yield is 13 to 16 metric ton per hectare per year and recommended for red soil under rain-fed condition. S34, it is developed in the year 1990, and parents are K2 open pollinated branches. It has a erected branches, small, entire, cordate, thick, dark green leaves with a waxy margin. Moisture content of 75%, protein content of 24%, rooting ability is limited to 75%. And it is recommended for rain-fed area with a block cotton soil and developed in the year 1990, that is S34. Another one is MSG2. The pedigree or the parents are BR4 into S13. It has a large entire cordate, smooth, dark green leaves. Moisture content is 77%. Rooting ability is limited to 80. Protein content is 25% and carbohydrate is 28% and chlorophyll is 0.22% and leaf and cocoon ratio 21:1 and harvest index is 0.55 and leaf yield is about 23 metric ton per hectare per year under rain-fed condition. There is another variety called AR12. It is suitable for alkaline soil and pedigree is S41 and Berampur C776 are the parents. Moisture content is 77%, protein 23, carbohydrate 21, chlorophyll 0.32, leaf cocoon 22:1, harvest index 0.55, leaf yield 17 metric ton per hectare per year, leaf yield 23 metric ton per year with soil reclamation and press mud about 40 metric ton per year per hectare in 2 splits and gypsum 8 metric ton per hectare in a mixed irrigate. This is another one called RC1 variety. The mulberry for low input condition of irrigated and fertilizers. The pedigree is Punjab local into Kosa. It has a large entire cordate glossy leaves. Moisture content of 73%. Rooting ability is 85%. Protein is 23. Carbohydrate 18. Chlorophyll is 0.25. Leaf cocoon ratio 20:1. And leaf yield is 23 to 25 metric ton per hectare per year under 50% of NPK and irrigation. This is Sahana, another variety for shade tolerance, especially for intercropping with coconut. K2 into Kosan is the parents, large, entire cordate, smooth, dark green leaves, moisture content of 73%, rooting ability is 80%, protein 27%, carbohydrate 22%, chlorophyll is 0.33%, and leaf is to cocoon ratio is 21:1. Harvest index is 0.55. And this Sahana variety yields about 30 metric tons per hectare per year under intercrop with coconut of 40% shade. And there are some challenges ahead before the scientists or researchers. A shrinkage of cultivable land limiting original expansion, varieties with higher productivity and capable of utilizing marginal lands needed. Global warming affecting the growth and development of varieties of mulberry with higher plasticity, rooting, sprouting, branching, and growth needed. Emergence of new pest and disease varieties with enhanced resistance accomplished for the improvement of the resistance against the pests and diseases. Escalation of the labor cost, varieties of amenable and mechanization needed. Soil health deterioration, depleting of water table, increasing demand of raw silk, salinization of fertile lands, which are the more important, the future challenging heads that need to be accomplished, that need to be concentrated in order to overcome the problem and improve the mulberry varieties. And there are some byproducts obtained from the mulberry sericulture. Sericulture rearing activity generates several tons of mulberry shoots, silkworm excrement each year. 100 DFLs will give 1 ton of shoot. Silkworm pupae are the good sources of proteins, lipids, minerals, and bioactive components which are utilized. And poultry feeds prepared from silkworm pupae. Fish feed, CIFRI, Barakpur, CSR, they develop the fish food, poultry feed from the silkworm pupae. It has been formulated from Antheria mylitta and Silkworm bombyx mori. And food products prepared from silkworm pupae, pasta, cookies, beverages mixed with myelinase, an enzyme which has been attributed to observe the usages of the mulberry. And silkworm pupae oil, a source of omega-3 fatty acids which are developed. About 30% of the pupae oil which is rich with omega-3 fatty acids. It has alpha linoleic acid, and silkworm pupae has both health and cosmetic benefits. Alpha linoleic acid reduces blood cholesterol, low density lipid, increases the blood high density lipids level. And the linoleic acid has a cardiovascular, neuroprotective, anti-cancer, anti-inflammatory properties. These are all some of the photographs. Hydroponics, sand culture, organic culture, sericin powder, sericin hydrogel, silk sutures, hydroponic cocoons, and culture cocoons, organic cocoons, and control cocoons. So these are all some of the benefits obtained out of the sericulture, especially mulberry sericulture. So these are all the some of the important findings relevant for the benefit of the participants from the sericulture point of view, more related to the mulberry crop improvement and future perspective is an insight. And